Okay, so this is assessment number 4, or reassessment on the on our fourth assessment, which was on kinematics. What I did is I kind of took a combination of problems and am trying to solve two different things. The first thing that we're going to look at is we're going to try to find how far a ball lands um, after being launched. So what it is the ball is 1 meter off the ground. It has a velocity of 19.6 meters per second, and it is launched at an angle of 30 degrees above the ground. And like I said, we're trying to find where the ball will land. So what we know is that our average velocity in the y direction is negative 9.8 meters per second. We have a initially at x, we start at 0. We're trying to find our x final. Y initial, we are 1 meter above the ground, and then of course our y final is going to be 0 because the ball will eventually hit the ground. Our velocity for in the x direction, so if you take this triangle and you make this is our x-axis and this is our y-axis, we can find that the velocity of x initial is 19.6 meter per second cosine of our angle, which is 30, and then in the y direction it's 19.6 sine theta, and like I said, our angle is 30. So what we're going to do is we're first going to find our equation for where the ball will land on the x-axis in the end. So we have x final will equal our x initial plus the velocity of x. And instead of using delta t, we're using just t because we are going to assume that everything starts at 0. And then for our y component, we use y final squared equals to y initial plus our initial y velocity t minus 1/2 gt squared. We know that our final y value is 0, so that we can then write 0 equals to y initial plus the velocity of y t minus 1/2 gt. What we're going to do is we're going to solve this for t. And the way we do this is by setting up a quadratic equation. We're going to use the quadratic equation. So underneath each of these parts, I have labeled that this part of the equation is c, b, and a. We are going to use the quadratic equation, and we eventually get that t equals negative vyot plus or minus the square root of vy o plus 2 gyo divided by negative g. You're going to get two different answers, and one positive and one negative. And so mine, I got t equals 8.97 seconds, and then t equals negative 11. And what I did is I took the positive number and you plug it back into our x final equation. So x final equals to x initial plus VOT. And then once you plug in the numbers, I got that x final was 137.4 meters. Not 100% sure if that's correct. I did kind of make up my own problem. But I also found the max height of the ball, or what was the highest point. Like I said, we already know our Vx initial and our Vy initial. And what I did was that we know Y final. We're looking for the change in y. And so we use the equation V final equals to Vy final equals V initial squared plus 2a delta y. We solve for delta y and get V final minus V initial all over 2a. and then if you plug in all the numbers, we get that the max height is 5 meters. And that is my assessment for kinematics.